Everyone. My name is Liam, and I had two projects this summer, and they kind of are very different, but also very similar. They revolve around the idea of like sustainable energy solutions, both in Anchorage and Fairbanks. So, it's the agenda, boring. So my project overview this summer, like I said, I had two projects. The first one was sustainable aviation fuel usage at the Anchorage airport. And this is not a new industry. This is something that's been around. But what is new is how ubiquitous it is becoming throughout the world. And then the second project is waste to energy, and that's specific to Fairbanks. The district heating system is something that is very valuable to take advantage of. So that's something that I found very interesting and something we looked into. So the projects kind of had a very similar outlook the first half of it, doing a big deep dive, becoming a subject matter expert, looking into the history of these things, the technological advancements. And this isn't just locally, but it's also globally and nationally. Specifically, Europe. Europe has a great process for both of these things. So that's something that I looked at and we looked at as a model for both Fairbanks and Anchorage, looked in a deep dive for regulatory framework. So some popular things I'll talk about later. And then kind of where they diverge is that in my SAS project, I created a carbon dioxide emissions calculator using live real-time data, and that's something I'll talk about later. And in the waste to energy project, I did some calculations and looked at like plausibility and feasibility analysis for Fairbanks. And then finally, both of these concluded with a research paper with results and some next steps. So next, I'm going to take a deep dive into sustainable aviation fuel. So Anchorage Airport is the fourth largest by cargo airport in the world. That's something I did not know before I came here. But once you start looking at the flight data and some of the history, it totally makes sense. A lot of the cargo that comes in through Asia goes through Anchorage, and it's a great stopping point. Some cool statistic I learned is that 90% of the world can access Anchorage Airport within 9.5 hours. So that is insane. So it makes sense why so many flights go in and out of Anchorage. So sustainable aviation fuels, like I mentioned earlier, are not a new thing, but their ubiquitousness has increased a lot because the supply of them has increased. So this is something that as costs come down, more airlines will take advantage of to help reduce their carbon footprint. Like I mentioned earlier, the regulatory frameworks exist, and specifically in Europe, there's some very interesting projects. So one of them is called Refuel EU, and by 2050, they expect to have nearly 2/3 of their flight fuel to be sustainable aviation fuel. Whether or not that will happen, we'll wait to see. But then in the US, we also have a project called the SAF Brand Challenge, and their goal is to get 10% SAF usage by 2030. So then technological advancements have changed a lot in the last couple of years because supply has increased so much. It's largely driven by the fact that it's cheaper and easier to create these fuels. A large portion of these fuels are created through like excess waste from farming or algae, etc. And then this kind of concluded with creating a live tracker, which I'll talk about now. So what I did is I took real-time data from the Anchorage airport and I used old data, and it goes back to 2018 to present. So it basically looks at all incoming and outgoing flights from the Anchorage airport. So any flight coming from China or Seattle or anywhere else going into Anchorage, coming or going, is tracked. So this kind of looks at all of the types of planes that come through, and it calculates the distance, and then it takes different values for, say, a Boeing 747 has very different flight emissions from a Cessna. So I wanted this to be as accurate as possible to kind of calculate what do carbon emissions look like and how could using sustainable aviation fuels kind of reduce that burden on the environment. So this is just for 2023. And in this example, let's say in a couple of years, we can have 20% sustainable aviation fuel percentage. And that could reduce, the metric tons of CO2 emitted by nearly 2 million. So, and then this goes in, and there's tens of thousands of data points each year. There's something like 80,000 flights this year or last year, and then there's some things interesting, which are like the top 5 airlines. But like origins, I found very interesting, which is like Hong Kong is the second most popular, and then Seattle's the first. That kind of made sense as a stopping point. But yeah, so I was really happy with this, and it took a lot of code and something I built. So I was really proud of that. So then the next project I worked on was waste to energy, and this was kind of like a project that Gwen was extremely interested in, and it's something that caught my attention, so I was very happy to jump on it. So what waste to energy does is it takes typical landfill waste, garbage, trash, etc., and it burns it, and that heat is used to turbine electricity, and then you get energy. But what's really interesting for waste to energy in Fairbanks is the fact that there's a district heating system, and then all of this excess heat that would normally just be wasted can be used to help heat homes, which gives it an additional advantage as a renewable energy source. So modern waste to energy plants are very different, and they've kind of changed a lot in the last 15 years. It's thought of, especially in the United States, that waste to energy plants are kind of like odorous and dirty, and this is simply untrue. It's just a false perception by the public, and Europe is a great example of why this is something that can be taken advantage of. So modern waste to energy plants take a lot of the excess emissions and bad gases and can actually use them to create valuable products like fertilizer. So some examples of European successes. Denmark is by far the most obvious example. It has a similar district heating system. And what they've been able to do is divert 95% of their waste from landfills. So over half of that is incinerated using like a waste to energy plant that is a possibility for Fairbanks, but then over 45% is recycled, and only 5% ends up in a landfill. And all of this is waste that has absolutely no use. It can never be used. Things like batteries. And then finally, waste energy is very interesting because it has existed before, which is what I'm going to talk about. Waste energy projects in Fairbanks are not a new concept. There have been two main projects, and they both failed. And a large part of the reason they failed is because they've been too small scale. They tried to take like paper from the University of Alaska Fairbanks and like the Eielson Air Force Base and just burn that. And they weren't burning all of it. And that was largely because the technology didn't exist to burn it all 15 years ago when these projects existed. So the costs were high, maintenance was bad, and then both of them burned out. So the issue was the technology, and now that the technology exists, this is something that can be used for the entirety of Fairbanks for all of the trash. And so I did some calculations looking at how much electricity could be created. So between 40 and 50 gigawatt hours per year, and that could power somewhere between 4,000 and 5,000 homes or so. And never mind how many it could heat. The calculations for that were a lot harder to find, so I didn't do that. But modular waste energy systems, so these are the ones that are basically like drop down, and they're built by several companies. The cost is between 50 and 100 million, and that sounds like a lot, but when you count the payoff and how much other energy sources cost, like the coal plant that was built here was around $250 million. So this is significantly cheaper, and it would reduce all the landfill waste that exists because of households and like the university and et cetera. Almost 80,000 tons of waste is diverted to landfills annually, and that could help power this waste energy system. So yeah, so my conclusion is that SAFs and waste energy are very viable systems. It will be a few years and maybe a decade before they become very popular, especially in Alaska, because waste energy is harder when it's significantly colder out. And same thing for SAFs, but this can be driven by good regulatory frameworks that can model after the EU and other places in the United States. I'm super proud of the carbon dioxide emissions calculator I built. It's not something I've ever done before, and it was like 3,000 lines of code, and I didn't know how to do any of it, so it just took a long time, and there were days where I would just sit at my desk and just bang my head. Because I started the day, and then I made my project worse, and then I don't know what. So that was frustrating, and the other interns know that I would, yeah. So anyway, I enjoyed learning so much of these different things about SAS, waste to energy, going on wild goose chases with Gwen about different projects like electric planes. But I think it was just like all of the part of the process. So overall, I really enjoyed it. And thank you.
I just want to reassure you that as a coder, ending the day with code that's worse than you started with the beginning of the day is
part of the process.
and that's my version control exists, so I'm wondering if
yeah. Revert back. So before none of it worked. So
the code share CrowdStrike. The waste energy prospects. Can you remind me what the energy conversion mechanism was, and how does it compare to the previous two attempts?
Yeah, so it's not that it changed. Like waste energy is, the process is fairly simple. Like they just burn it, it creates heat and steam, and then turbine, and then it creates electricity. It's different in the process of what they're putting in it. So waste to energy cannot be turned off. Basically, once they start the fire, it just keeps burning regardless of whether or not there is actual garbage. So it's very important that they have a constant waste supply, and that's something they did not have with the other projects, and they were very small. It was basically like paper pellets, and there's only so many paper pellets you can get, and it's not as consistent. But a lot of the projects, especially in Europe, use all trash, and they just throw it all in there, and then and the problem was that 15 years ago, they really couldn't collect all the fumes from that, right? Like if you're burning very odorous and dangerous stuff, you're gonna let out terrible emissions like methane and nitrogen oxides and stuff. And there are modern technologies that prevent that. So that's kind of the main difference, is that it's become broader, so it's more efficient, and they'll have more of a constant supply of stuff they can burn.
So for a system of this scale, it sounds like you would be capturing the majority of any methane, if not.
Yeah, it's like somewhere over 95%, and actually all of it that they convert, they can use a process that actually allows them to create it into a liquid, and then they can sell that or reuse it, and it actually makes it more viable because it's more economical.
My question was to toxicity.
Could you talk a little bit more about newer forms of emission control?
Sorry, say that again?
Could you talk about the newer forms of emission control and waste to energy technology?
Yeah, so they use something called like flue gas something, and it basically traps it, and then it's very similar to how a lot of modern like coal plants or other incinerating energy sources work, where they basically trap it, it filters it, and then they can harness it so that it doesn't get released. Kind of this like clean coal kind of similar idea.